All right, so let's look at your homework for tonight. I'm going to start with problems numbers 1 through 13. It's simply asking you, is the mapping, the table, the list of ordered pairs, the equation, or the graph, is it a function? And remember, we talked about in class how to determine if it is a function or not, you're simply going to either pass the vertical line test or your x's cannot repeat. Okay, so in order for our x's to not repeat, I need to have only one arrow coming out of each one in the mapping. Okay, so if I was to write these as an ordered pair, it would be -6, 4, -2, 1, 1, -3, and 3, -5. And you will see that none of my x's repeat, so this is a function. Okay, number 2, 5, 4, 2, 1, 0, -2, and -3, 1. Again, none of my x's repeat. There's only one arrow coming from each one. So yes, this is a function. Now, number 3, you will notice immediately that 4 goes to 2 and to 5. So there are 2 4s, making that a no. All right, number 4, we're going to simply look down the X column. All of those are different, so yes. Number 5, you will notice there are 2 5s, so that is a no. Number 6, there are 2 3s, so that is a no. All right, 7 and 8, again, we're just going to look at the ordered pairs. So all of these are different, so that is a yes. We have 2 6s, making that a no. All right, the best way to tell on the next 2 are going to be to graph them using your calculator, or you can make a set of ordered pairs. The graph for the first one is just going to be a line that looks something similar to this, so that is going to be a yes. And the same thing here, that is a horizontal line, so that is also a yes. Number 11, it passes the vertical line test. Number 12, right here, it fails the vertical line test, so that makes it a no. And number 13 also fails the vertical line test. So now starting down here with number 14, I won't do all of these, but I will do a majority of them. F of 4. Okay, now you notice there's an f of x and a g of x. So anytime it says f of x, we're going to use the f function. Okay. So f of 4 would simply be 3 times 4 plus 2. 3 times 4 is 12. 12 plus 2 is 14. You'll do number 15 just like number 14, except you'll use 8. Same thing with number 16, except you'll use -2. So it would be 3 times 8 plus 2 and 3 times -2 plus 2. All right. Now with 17 and 18, you'll see those are g's, so we're going to have to use the g function. So that would be 2 squared minus 2. 2 squared is going to give me 4, and 4 minus 2 gives me 2. Now don't forget, when you square a negative, that's going to make that a positive 9. But those 2 negatives right there make a positive as well, and that's going to give you a positive 12. All right, I'll do number 19, which is very similar to number 20, 22. So 19, I'm going to do f of 2 first. So 3 times 2 plus 2. 6 plus 2 is 8. And then I'm going to bring down my plus 1, making that 9. That's the same way you'll do number 20 and number 22. 21 and 23, you just do individually. So f of negative 4, so 3 times negative 4 plus 2 is negative 12 plus 2, which is negative 10. G of 2 is 4 minus 2, which is 2. Bring down your plus sign, and negative 10 plus 2 is negative 8. So that's the same way you'll do problem number 23. 24, you're going to start on the inside with f of 3. So 3 times 3 plus 2, which is 11. Then you're going to do g of 11. So 11 squared minus 11, or 121 minus 11, which is 110. Same thing on number 25. You're going to start with g of 4. So 4 squared minus 4. So 16 minus 4 is 12. And then you're going to do f of 12. So 3 times 12 plus 2, which is 38. And then for problem number 26, 4 consecutive even integers. So that's n plus 2, n plus 4, and n plus 6. So that the sum of the second and third, so that's these two right here, or 2n plus 6, equals 62. And you can solve from there.